All righty, welcome to another Tech Talk. Today we got Ryan McDaniel. He's going to be talking about front-end frameworks. Take it away, Ryan. Oh, before he does, everybody unmute yourself and let's give Ryan a round of applause.
Woo!
Let's go, Ryan.
Ryan.
Thank you so much, everybody. Good evening, and thanks for the introduction, Kyle. I'm Ryan McDaniel, and I'd first like to thank SingleSprout for sponsoring this Tech Talk, in which I'll be discussing front-end frameworks in JavaScript. The first order of business is to answer the question, what exactly is a front-end framework? In the most general sense, a front-end framework is a blueprint for front-end architecture and design, a literal framework upon which to build web applications. Frameworks give developers a base to work from while still allowing flexibility and functionality and design. There are two broad categories of front-end frameworks. The first is a UI framework, also known as a CSS library, which provides tools and templates for element positioning, styling, and coloring. These would be frameworks like Bootstrap, Semantic AI, and Materialize. The second category is what we'll be focusing on tonight, front-end frameworks that deal with app functionality and interactivity. In this latter category, at present, three front-end frameworks dominate the scene: Angular, React, and Vue. All three are fairly well known in the developer community, but which one is the most popular? Let's take a look at some metrics to help answer that question, starting with which framework has the most downloads. Here we can see that React significantly leads its competitors in downloads, racking up nearly 5 times as many as Vue and 10 times as many as Angular over the past 5 years. It's no surprise then that this next metric also favors React. In the monthly average of Stack Overflow question topics, questions about React are more than twice as frequent as those about Angular and nearly 5 times as common as Vue questions. What about general search frequency? If we look here at Google Trends, we can see that in 2016, Angular accounted for nearly half of all searches, twice as many as React that year. But by 2020, the numbers had nearly inverted, with React accounting for almost 50% of all searches last year. Vue, meanwhile, garnered next to no searches in 2016, but has grown to the point that it now almost matches Angular in search frequency. So far, React has had a clean sweep of these first three metrics. So is it the uncontested most popular framework then? Well, let's look at two other metrics. First, GitHub stars, where all three frameworks have continued steadily racking up stars in the past several years, but Vue has surpassed React since 2018, perhaps reflecting its status as a favorite in the developer community. Let's also look at the all-important job availability metric. Here, we can see that while React may have momentum on its side, Angular still accounts for nearly as many job postings as React, a fact that reflects the depth, breadth, and longevity of Angular's industry popularity. React and Angular between them comprise nearly 90% of JavaScript job postings, with Vue appearing in only about 1 out of 10 at this point. Given that all three of these frameworks then are popular and widespread, let's try to suss out the differences between them. First, though, let's look at some shared features, 3 in particular. Number 1, each of these frameworks is component-based, which means that individual pieces of the larger user interface are encapsulated into self-sustaining, independent microsystems called components. Second, all three frameworks utilize a reactive state where UI automatically derives from the data stored in that state. When state changes, UI re-renders responsively. Finally, when these state changes occur, the DOM is manipulated in order to reflect these changes to the user. React and Vue utilize a virtual DOM, which is essentially a lightweight copy of the real DOM. These two DOM trees can then be compared in order to make targeted re-renders. Angular instead uses an incremental DOM, which uses the real DOM to locate code changes, applying a list of compiled instructions to create the DOM tree and make changes to it. As this flowchart helps demonstrate, in all three frameworks, updates to application state on the left lead to changes in a tree of components, shown in the middle, which encapsulate application data. Updates to the component tree are then reflected in the DOM, shown on the right, where they can be viewed by the user. With these similarities in mind, let's try to understand what sets these frameworks apart. So let's first take a look at Angular. Angular is the oldest of the big three frameworks, and its original iteration, AngularJS, was created by Google in 2010. A sequel, now simply known as Angular, was released in 2016 and requires scripting in TypeScript. When Angular was created in 2010, its main goal was to separate DOM manipulation from application logic and to create applications that could perform well both in the browser and in mobile applications. Today, Angular has many more strong framework competitors than it did at its inception, and it stands out now for its bulk. That is to say, it is unquestionably a full framework, not a library. For that reason, and due to the fact that Angular code must be written in TypeScript, which is a superset of JavaScript that adds optional static typing, classes, and interface, Angular has a high threshold for entry and a steep learning curve. One of Angular's key characteristics is its use of dependency injection, which allows Angular apps to field high levels of complexity. In this defining design pattern, dependent objects, or dependencies, are created outside of a class, and their functionality is injected into that class at runtime. Dependency injection allows developers to separate the construction from the use of objects, moving the creation and binding of dependent objects outside of the class that depends on them. This separation helps to make code more readable, testable, and maintainable. At the same time, however, dependency injection is complex to learn and can make code difficult to trace since it separates construction from behavior. This brings us to React, as we saw earlier, by many metrics, the most popular JavaScript framework today. React was created by Facebook and released in 2013, 3 years after AngularJS, in response to the rapid scaling of Facebook and Instagram. Its original intent was to improve an app's ability to handle complex and frequent inputs, re-rendering locally and only when necessary. The first big difference from Angular is that React is much more of a library, making it lighter weight and giving it a lower threshold to entry. A React application can be started with just a few lines of code rather than requiring a broad project framework to accommodate it from the start. Although its lighter weight is often a benefit, one consequence is that advanced functionality often requires third-party tools. Thankfully for React developers, there's a massive React ecosystem with third-party tools to handle everything from server-side rendering to client-side rendering, from animation to state management, and a long list of other tasks. In terms of structure, React introduced JSX, what it calls a syntax extension to JavaScript, essentially syntactic sugar for combining JavaScript and XML, allowing developers to easily read and write HTML in React while still making full use of JavaScript syntax and logic. For state management, React uses hooks and lifecycle methods, which allow changes to application state based on changes happening locally within an app's components. These changes to the state are absorbed by the virtual DOM, essentially a lightweight version of the real DOM, and reflected in the UI through the process of reconciliation. In short, each time a component re-renders, a new virtual DOM tree is created. React's diffing algorithm then compares this new altered virtual DOM tree with the real DOM, finds the differences between them, and updates only the parts of the DOM that have changed. This technique is one of the biggest pros of React, as it saves unneeded work in re-rendering and makes for more efficient UI updates. Last but not least, let's talk about Vue. Vue is the youngest of the big three frameworks, though not by much, and was created in 2014 by a Google engineer named Evan You. While Angular and React are managed by Google and Facebook respectively, Vue remains independent to this day and is maintained by Evan You in tandem with the open source community. You created Vue not as a competitor to his employer's framework, but as a personal project, saying of its original purpose, what if I could just extract the part that I really liked about Angular and build something really lightweight? In line with Vue's goals, Vue is extremely lightweight and is considered a progressive, incrementally adoptable framework, meaning a developer can use as little or as much Vue code as she chooses, progressively adding or removing portions without having to redo the entire app. Its threshold for entry is perhaps the lowest of the three frameworks, and approachability is at the core of its purpose. Vue uses familiar HTML, CSS, and JavaScript syntax separated into separate sections of code. This familiarity and separation makes it extremely simple to construct interactive, declarative UI components, which is part of the reason it's beloved by developers and continues to gain popularity. Like React, Vue uses a virtual DOM, a copy of the original DOM that figures out which elements of the real DOM to re-render without having to re-render the whole thing. Additionally, Vue provides a simple, reactive, two-way data binding using what's called the vModel directive. In Vue, the V model listens to any input events or updates on the view or UI, then updates the data model or state with the new value. The data model in turn responds to data changes by updating the Vue template. In this way, data flows both directions, with the state updating the UI and the UI updating the state. So now we've reviewed Angular, React, and Vue. We're all set, right? These are the only 3 front-end frameworks. Well, not quite. In fact, there are at least 24 JavaScript frameworks and more than 80 libraries to date. If you include CSS frameworks in this discussion of front-end frameworks, the list of options for front-end development can quickly become very overwhelming. I mean, look at all these logos, and this is still just a sampling of all the frameworks that are out there. So how the heck do I decide which one to use? Each framework has its own strengths and weaknesses. If we stick to the big 3 frameworks that we just discussed, we can make some broad analyses that can help us to decide which one to choose. At a high level, Angular is a comprehensive framework that is best for complex, dynamic web applications. But keep in mind that it is a full framework that requires implementation in all corners of an application. React, meanwhile, is strong in high traffic, frequently updating apps, and it's particularly adept at building single page applications and progressive web apps. Its enormous surrounding ecosystem makes it versatile across many use cases. Finally, Vue is a great choice when flexible design structures are required. Since it's not yet as widely adopted as Angular and React, it may be best for smaller scale applications without large teams for the time being. But ultimately, there really is no wrong choice. Different developers have different preferences when it comes to choosing a framework. All 3 of these frameworks have tons of supporting documentation as well as thriving online communities, so you can expect to be able to accomplish whatever you set out to using any of the 3. I've included some resources here if you'd like to look into the big 3 frameworks or any other front-end frameworks in further depth after this talk is concluded. And I want to thank you all for your time this evening. I look forward to continuing this conversation in the future.
With that, everybody unmute and let's give Ryan a round of applause.
Yeah.
All right, and at this time, we'll take some questions. If anybody's got a question they'd like to ask Ryan. Oh, Katrina.
Hi, yes, I do have a question. Ryan, thank you so much for such an informative tech talk. So you mentioned at the end that there was no real best framework out of the big 3, and it was all up to preference and depending on what you use it for. So I was curious, in your personal opinion, what is your favorite out of the big 3?
Thank you for that question. And I'd say that the answer is definitely relative. As I mentioned earlier, framework preferences are personal and relative. They're based on the developer or the team, and they're based on the specific task at hand. Personally, I tend to favor React. Since I first started working in React, I've always really enjoyed the way the particular way that it implements component-based architecture. And I like writing in JSX, which allows you to intertwine your HTML and JavaScript code rather than separating it. I just find that really intuitive to work with. And then adding hooks and context API into the mix, and my own personal love for React has only grown over time. I'd say it also really can't be overstated just how many third-party libraries and extensions have been built around React. So there really is a tool or library at this point for every task under the sun. And I'd say combining the library itself and the ecosystem around it, my personal preference is for building in React.
All right, sounds good. Thank you.
Now it looks like we got another question from Rachel.
Yeah, hey Ryan. So outside of the big 3 frameworks that you discussed, are there any others that should be on a developer's radar?
Totally. There are so many great framework options. If I had to pick one to mention right now, there's a really cutting edge open source framework called Svelte that I didn't discuss tonight, but it's really been gaining traction over the past year or 2. One of the reasons it's been getting more popular is that the framework itself is very svelte, as in lightweight. It uses HTML, CSS, and JavaScript with only minor extensions, and it has fewer concepts and tools than some of the other framework options to learn for someone new to it. And then just like Vue, it's also a progressive framework, meaning it can be used to write small pieces of an app or to stand up the entire thing. And then on top of that, rather than doing the bulk of its work in the browser while the app is actually running, like the other frameworks we just discussed, it instead does most of that work in a compile step that runs only when it builds. So that produces smaller application bundles and ultimately faster performance. I would say that the biggest downside of Svelte is that for now, at least, it's a young framework. So that means its surrounding ecosystem is relatively small compared with those big three frameworks. And of course, there aren't yet many job opportunities for Svelte developers. But still, it is fast, it's clean, and its budding popularity suggests to me that it's a framework to keep an eye on and to learn more about, especially if you're a developer who really likes to stay on the cutting edge with front-end techs.
Awesome. Thank you.
All right, it looks like we don't have any more questions. If everybody wants to unmute one more time, we'll give Ryan another round of applause.
Bye, Ryan.
Yeah, Ryan.
Good job, Ryan.
Great job.
Nailed it.